Hello. Now, today we are going to be talking about putting this advice into practice. So I'm going to go through an exam question and as best as I can try and follow the advice that I am giving you. My timing will be a little bit out because I'm going to try and explain how it is I'm thinking through this, which takes longer than just thinking through it. So I have my question here. It's from 2017, paper 1, question 4. I opened up as much at random as I could any question and just picked with it so that I wasn't biasing anything. Now, first job is going to be to read the question. An amount of a substance remaining in a solution reduces exponentially over time. I'm going to pause there for a second. I can see a list of things. I can see day 1, day 2, day 3, day 4, and I can see stuff changing here. So I'm thinking this is a patterns question, that this is a sequences and series type question. And then I see this word exponentially. And that immediately makes me think geometric. Because if I'm dealing, I don't usually use the word exponential for a geometric series, but when I see the word exponential, it means two things in our course. It means we're either dealing with e to the x, e to the t, something like that. So a function, which is e to the power of something, or it means we're dealing with a geometric series. Now, because they didn't say the word geometric in an exam setting, I'm not likely to be totally confident about this, but it's certainly going on in my head. I'd be writing in a little note to myself like that. So let's continue reading. An amount of a substance remaining in a solution reduces exponentially over time. An experiment measures the percentage of the substance remaining in the solution. The percentage is measured at the same time each day. The data collected over the first 4 days are given in the table below. Based on the data in the table, estimate which is the first day on which the percentage of the substance in the solution will be less than 0.01%. Well, it says percentage of substance. Percentage of substance. Where else does it say that? Percentage of substance. So it's saying the same thing here. These numbers are part of the same pattern as 0.01. So this is first term, second term, third term, fourth term, in some kind of pattern, and I'm looking for a particular term in that pattern because they're talking about the same thing. So this is a Tn. I am looking for when Tn is less than 0.01. So I'm looking for, sorry, that should be a colon, Tn being less than 0.01. This is the information I'm pulling out of my question. Now, I'm pretty certain now that I've got a sequences and series question, so first job is going to be opening up the logs part of my, the sequences and series part of my log tables. But before that, I am going to follow my advice and break up my answer book into three columns so that I have more writing space. So I'm opening up page 22 in my log tables because I've recognized that I've got a sequences and series type question, and I want to have all of the different tools that I have available to me in front of me. Now I'm pretty confident I'm pretty confident I know what I'm looking for. I'm looking for the day of this. So I'm looking for a Tn, and I'm looking and the Tn is going to be on a particular day there's going to be a percentage less than 0.01. So on day blank we're going to be less than 0.01. So at some point on this day we're going to dip down below 0.01%. So I've written a note to myself down at the bottom right hand corner of what it is I'm aiming for. I've scribbled in a few notes where I can see things in my exam question, key phrases and things like that. And now I can jump into my question. So what I'm going to do, alright, this is day 1, day 2, and yeah, I've written that down. So I can see immediately that this is a pattern, and I can see that it's not a linear pattern because I'm not changing by the same amount each time. I've got this exponential up here that's making me think geometric. So how am I going to be sure? Well, I'm going to see if I have a common ratio. So what am I going to do? I'm going to write this down as a formula. You don't need to do that. Tn plus 1 all over Tn. That's your formula. You wouldn't need to write that down in the exam, but or when you're trying to think through a problem. But I am going to write it down for you here to remind you that this is what the formula looks like, because for some series questions you could actually be required to use that. Tn all over T1, which is 95. I put that into my calculator and I get 0.45. And then I put T3 all over T2 and see if I get the same thing. If I get the same thing here, it means I have a common ratio. It means I have a geometric series. And lo and behold, when I put it in the calculator, I get 0.45 both times. That means that that is my common ratio. So now I know I've got a geometric series. I'm writing down my Tn for a geometric series. That's my formula, again on page 22 in our log tables. And A is just first term, which is 95. So writing that down, I have 95 on 0.45 power of n minus 1. And what am I looking for? I'm looking for when is that going to be less than 0.01. Remember, these numbers are already percentages, so and this is a percentage, so we're looking for when Tn, which is equal to 95, 0.45 power of n minus 1 is going to be less than 0.01. Now, that's doing pretty good, and now I can see that I have some algebraic rearranging to do, and I see that I have a power is what I'm actually looking for. So I know I'm going to end up needing to use logs. So when I need to use logs, isolate the thing that it has the power in it as best as I can. So I'm going to divide both sides by 95, and I end up with 0.45 power of n minus 1 less than, when I put that in my calculator dividing 0.01 by 95, I get 1 over 9,500. And I know I need to do logs, so I'm going to get the natural log of both sides. I strongly encourage you to always use natural log for this. Otherwise things can get quite confusing. Because this is a power inside a log, I can take it down as multiply. This is the same method we are going to always use when we are dealing with powers, with variables as powers. We're always going to get the natural log of both sides and bring down the power. And at this point I would turn these into decimals and just write them to 4 decimal places. And when I do that, I get minus 0.7985, and this turns into minus 9.1590. and I now divide both sides by this. Now I'm dividing by a negative number, which means that this symbol is going to flip. Remember, you're dealing with an inequality, so you're going to end up flipping your symbol here. So we are going to end up with n minus 1 greater than, we divided by a minus number, we have to change that around, when we put that into our calculator, and we divide both sides there, we get 11.4703. Add 1 to both sides, and we get 12.4703, and that's days. So this is the about halfway through the 12th day. So on what day does the percentage of the substance drop below 0.01%? On the 12th day. So that's what we need for part A of this question.